So the ones we've looked at so far have been all in the gas state. Here we have calcium carbonate decomposing to form calcium oxide and calcium dioxide. As long as you have the solid present, its concentration doesn't change because the solid does not expand to fill the container. It just sits there in a lump. As you use it up, its volume becomes smaller as the number of particles becomes smaller, and so its concentration doesn't change. So solids and pure liquids, their concentrations don't change. So that would cause us a problem in doing these equilibrium calculations, because how do you figure out what the concentration of this solid lump of stuff is? Well, it doesn't change, so it actually doesn't matter. So anything whose concentration can't change, we just leave out of the equation. So calcium carbonate concentration can't change because it's a solid. Calcium oxide doesn't change because it's a solid, so we leave them out, and we find the KEQ is just equal to the concentration of the CO2. So aqueous species stay in the equilibrium constant and gases, but liquids and solids are left out. Let's look at this one. Here we have hydrochloric acid reacting with oxygen to form water and chlorine gas. Write the equilibrium constant expression. So KEQ, we're going to take the products divided by the reactants. Here we have water, liquid water. Liquid water, the concentration doesn't change, so we leave it out of the equation. We just leave that one out because it's liquid. Then we have this one, Cl2. The coefficient is 2, so we raise that to the second power. And then we're going to divide by the reactants. Both of these are gases, so we need to include them. We've got HCl to the fourth power because the coefficient is 4. And then we have oxygen with an understood coefficient of 1 and an understood exponent of 1. Any questions?
Why is water left out?
Water's left out because the concentration doesn't change. It's a pure liquid. So solids and liquids are left out because their concentrations don't change. Gases, the concentration can change. Something that's dissolved in water, if it says AQ, the concentration can change.